Good morning and warm welcome to all the participants of this program. Today we have the pleasure of having Dr. Elavarasan Krishnamoorthy with us. Sir is scientist, byproduct section, fish processing, ICAR-Central Institute of Fisheries Technologies, Cochin. And the topic chosen for deliberation for today's morning session is protein and protein derivatives from fish processing waste. Sir, you are audible and your presentation is also visible. You may start, sir.
Uh, Thank you. So, good morning to everyone. Straight away, let me go to the presentation. So, the topic I have chosen for this program is protein and protein derivatives from fish processing waste. As everyone knows, like the fish processing waste or seafood processing waste, or you can call it as aquatic food processing waste, it has got a huge interest because it has direct economical implications for the processors as well as to the producers. And another point is, if we look into this aquatic food processing waste, in terms of solid material, most of the wastes are rich in protein, and it varies with parts to parts, but majority of the waste, they are rich in protein. So uh, if we think of from research point as well as later for the industrial or entrepreneurship development, so anything working towards recovering this protein or developing the protein based products will have much implications in terms of the national economy. So moving on to the presentation, I believe that we have almost like experts in the field. I think there are no people from industry side, and maybe some of the scholars we have. And moreover, everyone has some interest maybe in the fisheries subject. That's how we are all assembled over here. So what this presentation will have, uh, information relevant to secondary raw material, probably in India, how much, the availability of this raw material, such sort of information. And then we will be moving on to the protein richness in secondary raw material parts wise, like which part has how much protein, and some of the process to recover these proteins, and some of the derivatives, like the process for making the derivatives. Then some of the technologies available with CAFT for utilizing the aquatic food processing waste. So these are all the points I would like to cover in this presentation, having around 70 slides, and I will run through the slides, and we can have more and more discussion rather than the monotonous presentation from one side, maybe in the second half of the presentation. So I no need to tell to the audience, because now everyone is like, you are all very much aware of how important the fish in terms of food security, nutritional security, and national economy. So what I want to like get your attention, the fish has got the phrases like nature's superfood. The reason it has got, whatever a person needs or expects from the food for his good health or well-being. So it's all served in the fish, except some of the nutrients, like they are poor source of carbohydrate, they are poor source of vitamin C. Other than that, like I think we have almost all the nutrients in the fish. So that's how, if we look into some of the FAO documents, you find this phrase, fish is the nature's superfood. However, because of the richness and various biochemical reasons, so they are highly perishable. Then definitely, if we have to make this material available for the consumer, we need to process it. And the moment we enter into the process, so it is obvious that is going to generate some waste, depends on the intention the processor has. So I just tried putting into the broader terms the sort of waste which are generated, like finfish and shellfish, and some of the waste parts. Like we look into the finfish, we have head, visceral waste, scale, skin, fins, and frame waste, sometimes the belly flops, and in some processing even the wash water. So these are all the waste one can expect. On the other side, if we look into the shellfish, like crustaceans, molluscans, and cephalopods, the major waste will be the visceral waste, and then the shark water, If it is crustacean, then we have shell waste and appendages. So these are all going to be the waste when someone intend to process fish, especially finfish and shellfishes, for the consumption or to export to some other country. So that's how the the sort of waste which are being generated. And what are we doing with this waste? Of course, on the other side, we have from regulatory bodies like pollution control board, then governing policies are there that these need to be disposed properly. Otherwise, it has to be managed in such a way that so the environment is being protected from such pollutions. But the processor look from the economy point of view also. So he may think how best we can reduce. So there are only two ways. Either you have to bring down the the amount of waste generated to manage the waste. Otherwise, whatever the waste generated, that has to be converted into certain products to again gain the economical benefit. So right now, most of the time we go for land filling. In some places, they may be treated properly, or more often it goes for the rendering process. So this is how we are utilizing as of the whole country the fish processing waste generated. So some of the possible products here and there are few industries, they are making the high value products or specialty products from fishery waste. But I think we have a very huge potential still to be tapped. So this is again the general figures, what would be the amount of waste generated. And if we look into the major products, and mainly this is for the export industries. Say for if they're going for processing shrimp products, again you may find different styles and different farms. Based on that, the amount of waste generated will vary. But anyhow, so if we need to generalize to get a concrete figure, somewhere closer to 45 to 55, that's the range of the waste which are being generated. I just want your attention to the surimi processing, which is the that's the processing technology that generates almost 70% of the raw material as waste. And the least one we may find it in whole and gutted fish, because only the visceral portion is going to be removed. So otherwise, in general, we can put the figure into somewhere from 35 to 55. Sometimes it goes to 65. But if we want to throw the idea, probably the 50% of the material, whatever we produce, is being converted into waste. Their utilization is a different aspect. Some of the some proportion may be used, but still there is a major portion that is not utilized. So here is an example. So the idea of generating this sort of data, so assume that we are going to develop an industry based on the fish waste utilization, probably an integrated unit where all the parts is going to be converted into one or another product. Then the basic information which is to be available is parts wise. How much actually the head is, how much the scale is, how much the skin is, how much the fin is, how much. So this is what the information, basic information, which actually we are lacking. So this has to be again generated species wise, because some of the species, for an example, Indian major calves, the scale is the best raw material for producing a protein derivative called collagen peptide. So, but do we have a concrete idea how much is there in India? If someone wants to put up the unit, in which location it is highly available? So lacking such information is actually hampering the growth in secondary raw material utilization. So having that in view, I suggest, because most of the participants are from the academic side, it would be good to generate a database on the commercially important fish and shellfishes of India. Depends on the style of processing, style of product or form of product, the quantity of waste generated, and the waste and what is their potentiality for which product this is the most suitable one. So such sort of information need to be generated. So if you look into the data generated for the Lathrina species, I think the major waste is the head, then followed by the frame waste. And if we look into the scale and all, it's pretty low. Again, this quantity will vary with the type of fishes, and even the quality of the fish which we are taking for generating such sort of information. So it doesn't need much, probably reasonably a good quantity of fish to be evaluated for producing such sort of information, and that has to be made available for the public, for the probably for the startup companies. They may be looking into such sort of information. So we tried developing for few fishes, and I have placed it in the presentation for an example. Like we have done it for the Pancasius also, we have it for the croaker. So this is just a weight composition, and I again and again reiterate that this data as a whole country need to be available for the better development in this particular sector, that is that fish waste utilization. So this is again the global status. The data what I have presented is little older, but still it holds good, and an amount around 32 million tons of waste globally available. And again, some of the basic information, like 40% of fish consumption undergo industrial processing. So that's how the assumption was made, and the then it was all calculated. So just to say in a point, more than 32 million tons of waste are available globally. And if we come down to India again, we have almost this slide shows how much we are exporting. Pretty old data, probably 3-4 years old data. So the numbers are not important in this context, in today's presentation context. But what is important is, so from this information we can actually derive the amount of waste which are available, but nowhere it is being reported, but it is a known fact also. Almost 5,26,952 tons of raw material in the form of waste is available, especially from the processing sector, which are the people who are exporting the raw material in form of such products, the processed form. From that particular sector, this much is available. So if we take overall, even if we take the domestic market, and if we make sort of permutation and combination and derive a sort of calculation, then we end up with almost 3 million ton is the secondary raw material as on for 2018. Probably now the figure based on the production value, it would have gone up. And then we come down to the protein richness. Fine, we have this much of raw material available for the industrial utilization. Probably a certain proportion definitely is being utilized already by fish meal industry, then probably the shrimp meal. These are all the major industries which are actually utilizing. Other than that, we have sort of value added products like collagen peptide. Then of course we talk about gelatin a lot, but I think we have hardly a unit on fish gelatin production. One or two probably. Nita Gelatin from Kerala, then Gadre Marine. I think they also do to some extent, but it's not a very common industry if we consider as the whole country. Probably we can the further research and all those things can be directed towards filling the gap between the research and the industrial development to better harness this raw material. So coming down to the skin, I would generalize. We have around 13 to 22% protein, and the nature of protein, like the type of protein, is mainly collagen. Then again, I have listed for Katla and Srinas Mrigala. These are all the values taken from the published work, and almost 20 to 24% of proteins are reported for the skin from Katla and Mrigala, and some of the shark and for tuna. So the collagen content as well as the hydroxyproline content, these are all more relevant, but we no need to worry about those values in this slide. Only we can look into the protein content. So we can say almost as good as the edible portion in terms of protein. I'm not talking about the quality of protein or nature of protein. In terms of quantity, almost it is equivalent to the edible portion, and we have around 15 to 22% of protein in the skin also. Coming to the scale, this is again another major waste, and we have again around 17 to 22%, and this can vary from species to species. The reason to show this slide are, probably you all aware that what is new in this. We know that scale has got this protein, skin has got this protein. I'm trying to link why this sort of data is important, rather than directly, conducting some research or some trial on the process. The basic information also need to be generated in a wide scale, and it has to be like in a form of database accessible to everyone. I think in this context, all the academics side, the teachers, the researchers, the scholars, they have a huge role to play to fill this gap or to generate this data. And again, coming to the head waste, this is again another major waste. On the wet basis, the protein content is around 13%. And again, on the side, other side, pink perch head waste, so 17.57. The reason, these are all the important species for the surimi industry, and there the head is again the major, type of waste which is available, which we can actually explore it for other derivatives or, the value added products. Then if we look into the shrimp head waste, another major raw material. So head waste is again the important thing rather than the cuticle. Of course, cuticle has also got almost equivalent amount of protein in terms of value, and we have around 11 to 13%. And we need to remember, if someone collects from the industry this head waste, and if they try to profile, they need to, take care, avoid the mixing of water along with that, because the tendency in the processing unit, because as it is not having much value, more often it is just dumped along with other other material like chilled water, and blouses and other foreign material. So that should not be there when you quantify. If the water is there, it will actually dilute the protein or your values. You may end up with the 6%, 7% value. So that's the reason I'm emphasizing this. So if someone is intending to make a profile or a database, maybe from the secondary, from the literature, if they're trying to build the database, all those points to be taken care, then only the value reaches the end user in a proper form. This is again the general composition. Okay, forget about the fin fish, shellfish, and all those things. If we want to generalize all the fish processing waste, probably around 55 to 60% on dry basis. So that is the protein content, and that is the very huge amount of protein which are not actually recovered completely. Probably 50-60% of the raw material we are using even today, mainly for the meal industry, otherwise is not being utilized to the best of my knowledge. So coming to some of the technical aspects, now we are aware that there is a huge, just to summarize, we have a huge amount of raw material, and this raw material is rich in protein. I have not mentioned about the fins, frames, and bones. Definitely they have protein, of course collagen, but if we in terms of content, if we look, the minerals will be more. So that's the reason I'm not showing much emphasis on those raw material. I'm showing it on the scale, skin, then the head waste, where the protein content is really rich. So those including the visceral waste. So in those raw material can be focused for this presentation contest. And I don't need to say what is protein. Of course, everyone is aware. I'm talking about the participants, so they are very much aware about what is protein, their definition, their chemistry, and all those aspects. Probably we no need to talk on those classes, but still just to categorize. So I'm trying to categorize three categories, like muscle proteins, then of course we have then water soluble proteins, connective tissue protein, salt soluble protein. Probably this is available already in the textbook. The standard textbooks, they have what are all the water soluble proteins, what are all salt soluble proteins, why they are called, those terminologies and all those things. What I want you to remember, the fish waste rich in all these proteins, water soluble, salt soluble, connective tissue proteins. You find it depends on the parts of waste. And there are some special proteins like keratin protein, blood proteins, then egg or milk protein, prolamine, and those sort of proteins. So these are all available. why we need to talk about which is the protein available. Probably tomorrow someone is interested only extracting the myosin, marketing it as a product, maybe to the academic or for some industries or for some medicinal value, that they wanted to do it. Then they need to be aware of which parts of the waste will be rich in myosin, because that's more important. If you want to run a industrial process flow and someone wants to do collagen peptide for the pharmaceutical application, then they need to know which parts will have better purity, say for swim bladder. Probably that is the part which has more and more of collagen and very much pure form compared to any other material. So that's the purpose I'm placing this slide and trying to get your attention. Then moving on to protein derivatives, I have again tried putting into different category. Say for conjugated proteins, then hydrolyzed. Conjugated in the sense, probably the broken one again conjugated with other moieties or other molecules, and based on their values. Say for conjugated proteins, probably they can have, as per the literature, they have better functional properties. Say for hydrolyzed fish protein, again they are reacted in such a way to form some plastins. So they are known as functionalized protein. They have improved functional properties compared to broken proteins or the whole protein. Then maybe another category, these are all peptides and hydrolysates, even some of the free amino acids. They can be utilized for a nutritional as well as the nutraceutical sector, because these are all interesting areas in today's trend, especially from research as well as from industry. Then we have the high value material like conjugated peptides. So once you break the protein, then you can try conjugating other molecules, even the medicinal molecules along with them, so that they can be used in terms of delivery, bioaccessibility, bioavailability. Those things can be enhanced. And this is the area probably from the academic side we may need to target more developing such sort of molecule for the very high value industry. So this is the overview. The protein derivatives can be classified into three forms, and you can take some information from this and further to refresh your knowledge and to further carry out sort of research or placing some projects. So probably this forms your key information. And moving on to the processes, and we have in today's context so many techniques, so many processes, very advanced. But what we need to think when we work on some processes, one is the academic interest, another one is industrial interest. In the academic interest, we need to be very much ahead of industries, and we have to foresee probably after 25 years what would be the most intelligent and viable technology to recover these important molecules. So we should focus in those lines. But when we come down to industrial aspect, if you add more and more intelligence in the process and more processing steps, and that brings more and more cost to the process, so it makes the process probably non-viable. So it won't get adapted to the industry. And these aspects we need to balance. One side we need to carry out very advanced research, and on the other side we need to think of their industrial utilization and commercial utilization. That's how whatever the research we do, that turn into some economic value. So, and not ending up with the publications. So I'm talking it has to reach someone. So to channelize that, we need to balance this research and we need to fill this gap. And here I just tried listing out the type of processes: the mechanical process, thermal process, and the now very much interested. Yeah, huge interest is over there. This alkaline solubilization and acid precipitation. Along with the PI process, again you can put some innovation, like you can add particular salt, particular solvent during the process, and even the heat, either to maximize the solubility of protein or maximize the recovery. Probably we can work on those lines. Also, another thing is the filtration techniques. Now the filtration techniques have so much advances. So it goes up to nanofiltration. Even a particular enzyme can be just purified out of this fish waste. So probably we may need to focus on developing the machineries, refining, perfecting these filtration techniques which can better suit our industry and our raw material, our process flow. That aspects also we need to look into that. And the enzyme process, I think this is the most wanted process in today's context, because we don't use harsh chemicals. So in terms of sustainability, sustainability in the process, sustainability in the environment, tomorrow, that having the minimum effluent, I don't say zero effluent, the minimum effluents. So for all those aspects, probably the enzymatic processes can help. And again, if you look into the enzymatic process, the major input is the enzyme. So again, their specificity, their type, and the nature of raw material, all those things need to be worked out if we need to develop a successful enzymatic process. And you can put any of the mentioned process in combination to achieve the sustainability in terms of process as well as the environment. I'm not dealing any of the aspects in detail in this presentation, because most of the participants are teachers. They are very much aware of it. Otherwise, also probably they get from the literature if they are quite interested. I'm just refreshing what are all the processes are there, so that someone can go back and ask their students or themselves to do sort of research to bring out the information which are more useful for the industry as well as academic. So coming down to the Indian scenario, then one of the major raw material, because making centralized system to collect all the waste, that is a major problem to be worked out, how best we are going to collect. Just for the information, I'm throwing the idea, maybe the model like Swiggy, Uber, like how they collect the people from one place and take the person to the another place. The similar model, probably a little refined mode, we can set up like district level hubs where the secondary raw material can be at least pre-processed and stored, and such models can be worked out, and we can demonstrate with the help of startup companies or these softwares, because those applications are so important to connect the people, so that from the major landing centers and the major fish markets, at least the waste can be collected and placed it available for the major processes. So probably the scale can be processed and supplied to the industry where the collagen peptide is being produced. The skin can be processed probably in the frozen form, that can be sent. Probably we need to do a sort of pre-processing or primary processing, and we need to establish primary processing centers. So that takes still more time, and we need to work out. So I'm not going to say something about this domestic waste. What I'm focusing is again the export industry, where the material is readily available, and more often the industries are located in a park sort of style, like many number of industry in one place you will find it. For an example, in Cochin, Arur industry area, you find all the processing units. So from such location, it's very easy to collect the material and making use of it. So I'm talking about the frozen and chilled items, the amount of waste generated, what sort of products are being utilized, and what sort of products can be generated, and what is the technology available with CIFT. So as you are all aware, the manure and fertilizer, simply it can be put into some we can dig a place and allow them to decompose along with the soils and other leaves and other sort of things, so to make into manure, so that can be utilized as fertilizer. Even though they are all underutilization, but still it is being practiced. At least those things have to be done. But the issue is the smell. When it get decomposed, how the people in and around going to react. So those things will add to the complexity of implementing such practices in all the places. And then we have another product, fish meal. Everyone is aware of how it is being produced, and this is the one industry, I think, in today's context, lifting most of the secondary raw material and converting into some form. Then we have the fish silage. So very well proven technique, but still it is very limited to individuals. Some individuals here and there, they are practicing and marketing this product. Then what are all the protein based products we can develop? fish protein hydrolysate, collagen peptides, and fish gelatin. Because the waste are like heads, operculum, scale, skin, visceral mass. So those items are there. So, and we have technology for all these products like silage, meal, fish protein hydrolysate, collagen peptides, gelatin hydrolysate, and fish solubles. And these are all some of the edible products. Relatively the larger fishes where you have good amount of meat in the shoulder portion or in the frame, you can call it as neck portion or head portion or shoulder portion. So those areas, like the bigger fishes like tuna, grouper, the processing industries, they used to generate a lot of meat along with them. Simply they can be cooked and picked to convert into value added products like cutlet and other even like burgers, and wherever the cooked meat can be used in those places, in those products, such sort of materials can be simply utilized. And this is one important product. I think we don't have much of the information, but is being done elsewhere. Fish head broth soup or fish head broth as stock, even it is in a canned form, in tinned form, it is being sold and exported. It has got a huge health benefits. So I'm not going to list out. It has, because it has collagen in the head portion. Other than that, some water soluble proteins are there. So that forms a very good stock or a soup ingredient. So it has to be simply boiled to extract the collagen along with other seasonings. And this process can be, we did a small work on this, but including the digestibility and all those aspects we have worked out. Probably, we can, the academic side, we can work a lot on this particular product. It has got a huge scope also in international market. And this is another process. I have listed out some of the literature, some of the raw materials they have worked in, like alkaline solubilization and acid precipitation. I think you have a separate presentation also by Dr. Vijay Reddy on this topic. So simply the process flow goes like this. You need to homogenize the raw material, then you need to solubilize by adding alkali. You can choose the type of alkali you want. And after alkaline solubilization, we need to centrifuge. I'm not telling any conditions. Why? Because that need to be optimized for each and every raw material. So this is the general flow. Once you solubilize the protein can be recovered in the supernatant after centrifugation process. Once it is centrifuged, then again it is taken back to the precipitation point, probably 4.5 or 5, depends on the raw material, that again need to be conformed in a laboratory trial. Then it has to be implemented. Once it is precipitated, that is again neutralized or washed in water to remove the salts. Otherwise, the presence of salts in the isolate is the major drawback. So that need to be removed. Otherwise, at least it has to be minimized to the level where it doesn't affect the perceivability when it is added as an ingredient in the product. Even surimi industry, they are trying to explore this process flow. Why? Because the water soluble proteins are also recovered in this process. So the yield wise, it is improved and almost a similar sort of quality it gives. But what we need to think when we thinking of taking this process to surimi, the idea of removing the water soluble proteins are to remove the fat. Even though some fraction of lipid are thrown in this PI process, means removed as a skin or as a solid over the surface when you do centrifugation step, but still because of this solubilization and stirring and all those reactions, emulsification is happening. So it traps some of the lipids, probably that may affect the surimi quality. So that need to be worked out. Even though there are some literatures, some research reports are available, when we think of the commercial aspect, such points to be taken into the account. This is about recovering the protein by PI process. And these are all some of the waste which work which we have done, recovering gelatin from the head waste, and also protein hydrolysate from the recovered protein. And here are the table. So forget about the work what we have done, and here is the table what can be done from the head, the phyletic frame, bone, and almost these are all the known products: collagen, gelatin, collagen peptide, fish flour, fish protein concentrate, fish protein hydrolysate. These are all the product which we can generate from chilled or frozen processing industries waste. So this is again fish meal, and the future of fish meal industry actually lies in utilizing the fish waste, because now there is a pressure from the government bodies and other social uh, protecting society protecting organization, because sardine is the major raw material, and that's one of the wonderful food fish. So people doesn't like in some occasions utilizing this material for meal industry. So even all the Indian fish meal industry need to produce the sustainability certificate that the catch what they are using is not affecting the resource, future stock will not get affected. Then only the industries are also being allowed to use this raw material. So in this context, slowly there will be a pressure building on that, because on the other side there is an increase in consuming the sardine or in general food fishes. So the material will not be available to run this industry for in the future. Then the sole raw material will be the processing waste. Now 30 or 40% of the fish meal raw material replaced by fishery waste, but still it is not 100%. But in the future this will grow. So what could be the problem in utilizing the fishery waste? The fish meal what we produce, if may not end up with a very high amount of protein. So rather than 65%, 60%, we may end up with 45% of protein, because the fishery waste will have a lot of bone and other material. In today's context, almost all the surimi industries waste, the mixed waste, is being lifted to the fish meal industry. They find it more reasonable to utilize for fish meal industry rather than taking this material for collagen peptide production, because yield wise the process which is available affects the recovery. Yield wise it is low. Again the quality comparing to the collagen peptide from scale to the mixed waste, so the one comes from the scale has got the better quality. So almost no smell, the taste, the acceptability, the solubility, everything is fine. But when we go from the mixed waste, these parameters are being affected. These are all some of the personal experience based on the work we have conducted on the mixed waste from surimi. So when we talk about this, say rather than I opt for this process, I would go for fish meal industry, because 4 kg if I put, I may end up with almost more than a kg. So that is going to fetch me better money than the collagen peptide production. So this is the statement from the industries. So the fish meal industry will be one of the major opening for utilizing the rest raw material or secondary raw material, and is being practiced. Then this will be increasing in the future. So this is the again the process flow, how it done. If somebody is outside the fisheries, outside the fish processing, in the participants, then they may they may show some interest in the process flow. Simply the raw material, the fish offal, is ground into paste. Through the screw conveyor it is shifted, and it is going to a cooker, where it is cooked. The cooked raw material is again sent to the tricanter or decanter to separate the material into different fraction. The solubles, the lipid, in the sense the oil, then the major mass, the wet mass, that will be, you call it as press cake. Once it is passed through this tricanter and press cake, means the screw press machine, then the press cake is sent to dryer. Sometimes even the solubles are sent back to the dryer to enhance the yield. So what is interested, if there are people in the participants already, they are very much aware of this. So what is the message I would throw for their future research is, they can work on recovering this oil, because more often the stick water which has oil, that is in the emulsified form. Even the enzyme industries are trying to market enzymes for this process to improvise the oil recovery, so that even if the oil recovery increased by 2%, so that will make a huge impact in terms of processing tons of material. So probably the research can be focused on those areas, recovering the oil using enzyme technology. On the other side, the evaporator, or the like falling film evaporators, or those machineries which are used to concentrate the fish solubles. Fish soluble is means the stick water is concentrated and converted into a product called fish soluble. So this used to have a lot of scales. removing the scales, they again put a lot of acid that forms a huge effluent. Probably there the focus can be, if I add what ingredient, the scale formation can be minimized. So that sort of work can be taken. And other things, bringing down the smell. Already the scrubbing technology is available. Whatever water generated, they are all collected and they are passed through water to remove the smell. Otherwise, setting up this industry is a huge issue. So people around, more often it is not in the residential area. Even though it is far away from the residential area, the smell will be the huge issue when it get mixed with the atmosphere. So more than throwing some technical information, some of the personal experience I'm putting into this presentation, the reason is many of the participants aware of these processes, this mass balance and all those information. Probably the research can be diverted towards other areas also. And one more thing, each and every raw material, every waste parts need to be standardized for any process, including the meat production. So here is a projection by 2030, how the raw material replacement can happen, using the whole fish that will be replaced by the utilization of fish byproducts. So it goes to a huge extent. Almost half of the production, the predicted production, will be from the fish meal production from the fishery byproducts. If fish meal industry get affected, definitely the aquaculture industry will get affected. So that will again weakening the link up to the production. Whatever the target we talk, whatever the doubling the income, aiming the all those things will get affected. So another product is fish silage. Again, this is the process flow. Probably you find the information in FAO. So this can be the well standardized material for fish silage. So what is not, this is a known fact. So I'm moving on to the another information, the fish ensilage. Especially if you can find it even in Amazon in the name of fish amino acids. So biological way of making, or the rather than biological way, it's a fermentation, adding jaggery and producing. So the problem with even this industry is the duration it takes. The fermentation process takes around 21 days. You add sugar or jaggery to convert the fishery waste. One of the beautiful process to utilize the whole fish waste, but make sure that it has got the visceral waste. If you are going for silage, the visceral waste. If you are going for ensilation, probably the intestinal bacteria will help to enhance, the natural bacteria will help to enhance the fermentation. But some people, they used to inoculate with platinum. And now if there are people from microbiological side, they can think of developing a consortia of microbes that can bring down this fermentation period with minimum jaggery or other inputs. So speeding up the process, so that can be taken into another information for the future line of work. Then moving on to the fish protein hydrolysate, I think one of the major fish products in last decade, if we look into the literature, a huge amount of material, research, information available. But if we look into India, how many fish protein hydrolysate industry we have? Hardly one or two, that too for the agricultural application, not for the human consumption. But the process is so good in such a way that we can develop the product for human consumption. The problem to be solved is again the bitterness and smell. Once these two aspects we could solve, then it has got a huge market potential, even from the fishery waste. Any raw material is good for going for fish protein hydrolysate, provided that they have desirable amount of protein. So almost the fish waste pods can be utilized for this product. Again, little bit of chemistry of hydrolysis reaction. It's all about adding a water molecule and breaking a peptide bond. So I'm not going to define what is a peptide bond, what is the pipe, the partially double bond or a covalent bond, all those chemistry I'm not going to talk. I'm just placing it. You can focus more on this, how to increase the specificity of enzyme towards certain region, so that we end up with a product that has got a huge biological potential. So this is the general process flow. Again, take the raw material, add water, homogenize, then subject it to hydrolysis. Choose the enzyme very carefully. Carefully. Probably a research can be focused on developing the enzyme cocktails, a combination, rather than going for a single enzymes, then the heat processing, then termination of hydrolysis process, then it is put into the filtration process, then the soluble fraction and insoluble fraction. So in academic side, what is not worked out in this product is the insoluble fraction. So the insoluble fraction is also a hydrolysate, better than the fish meal, probably a little bit inferior than the soluble fraction hydrolysate in terms of bioactive potential, because it lacks water solubility, so that can affect many of the applications. Otherwise, they are also as good as the soluble fraction protein hydrolysates. So what are all the research can be done? Probably you can focus on the drying technology, developing a drying technology for fish protein hydrolysate. Another issue is high hygroscopicity. We can add, coming up with adding some carriers like maltodextrin and other known carriers, or simply adding some anti-caking agents. So those sort of works can be carried out to enhance the knowledge available to fill the gap in this area, so that this is getting translated into some industry. These are all some of the works we have done on protein hydrolysate. We have done actually extensive work on fish protein hydrolysate. This is again a work on gelatin. So the information is, if you are working on fish head, other parts, the bloom strength is pretty low, so it may not meet the quality of what you are producing from skin or scale. The gelatin may not meet the quality of those raw material, but these can be better raw material for producing collagen peptide or some biofunctional ingredients. So for those areas, this can be utilized, because there the molecular weight, the bloom strength is immaterial, because they are all already broken. The functionality is important. So for those areas, these sort of raw materials can be put out. This is again process flow, how it's being done. So demineralization, deproteinization. We try to bring down the usage of alkali by simple cooking and making the gelatin in dried form. And these are all other derivatives like gelatin powder. These are all some raw material, and the picture shows the gelatin powder. Then this is the collagen process. Rather than collagen peptide, if we can produce collagen, that has had a huge medical as well as pharmaceutical applications. But the problem is, whatever the process we have worked out, they are all too lengthy, including dialysis, and it goes for days together, almost 5 days. Even the laboratory work will go for up to 5 days, and inputs are like a high concentration of acids, alcohols. So these are all the inputs actually making the process unfit for the rather than unfit, complex. The complexity increases for this process to adapt in industries. But we don't find any collagen industries in India, but they have huge pharmaceutical and medical application. When they are going for such industries, the price also goes very much high. But we are doing collagen peptides and we are exporting also. The cost goes somewhere around 800 to 1,200 rupees a kg of collagen peptides. There are few units they are doing, and the major raw material is again fish scale, and especially from freshwater crops. So even though we talk so much in the research from bone, scale, skin, but finally the industry adopts only scale, because especially freshwater fish scale, the smell issue is not there, and impurities issues are not there. The process is very simple. They go for directly boiling, because when it is collagen peptide, they don't worry about the bloom strength and all those issues. So they go for boiling, then go for enzymatic hydrolysis, then some purification steps like microfiltration or ion exchange, treating with ion exchange resins. Then they end up with the whitish powder, and it has got a huge application, including human consumption for arthritis. I think now collagen peptide tea is available. So these are all the things we can work on. Other raw material, forget about the freshwater carp scale, now is being utilized very well. From the marine source, the smaller size scales are actually not preferred by the industry. We can work out what is the difference between this small scale and bigger scale, why it happens in industry, adaptability issues. So this is again on the fish maw. I think our export has come down. It is simply collecting, drying. But firstly, I have seen even in your small markets, if the retail market, they collect this swim bladder, wash, then sun dry it, and some fellow comes and collect it over a month, once in a 3 months, 4 months, they come and collect, then they are taking it for the export. We are not doing much research on fish more. Probably we can focus on this also. Still, we can improvise the quality in terms of shelf life, and all those things can be worked out. And another important product, the protein-based products from fishery, or secondary raw material or seafood waste, whatever you call it as, fish enzymes. One of the important area, almost we can say only a step we have placed it in this area of research. We end up with some small scale lab, few milligrams, and we probably we need to focus more on this, putting into an industrial scale. Then only the utilization of material it goes. And more often, this involves isolating the particular enzyme fraction. We can keep making crude enzymes and making it a stable product, and commercially we can test on industrial application, say for the chitin industry, where deprotonization, fish enzymes may do better deprotonizations. So in such areas, these things can be worked out. I have just listed some of the utilization of fish-based enzymes, the literature to have reported. So we can focus more on this fish enzymes research. Then moving on to the shellfish industry, the major raw material is shrimp industry. So I don't need to say that we have huge amount of shell waste. Even though the chitin industry is using this raw material, even it is not to the appreciable or the level that has to be appreciated. So recently we have worked out enzyme-based technology for chitin preparation with minimum effluent. I don't say zero effluent. There is effluent, acid alkali effluent, but still the quality of effluent, or the system needed to treat this effluent in terms of cost is pretty low. That we have done a huge amount of work, and we have worked out the economy, and we have transferred this technology also to a startup from Gujarat, Longshore Technology. And now the trial, the last 1 week, the trial is going on. So we are trying to demonstrate in pilot scale level. And I don't need to say it has got a huge amount of protein in terms of dry basis. And here I have given different components which can be extracted. Again, this is from a research paper, biorefinery approach. So if you take a kg, how much we can recover other components. And in this, again, the major protein-based components are like hydrolysates, then carotenoproteins. Rather than pure carotenoids, it can be marketed in a paste form. If when we do enzymatic process, you get the precipitate, or what you call the residue, that is almost in the paste form, that can be acidified, and it can be utilized in aquaculture feed formulations. So what is happening in India? Already the shrimp meal is produced, even is being exported, and I have already placed the value also, almost like 50 to 60%. And domestic consumption is very huge, and this is one of the protein-rich shrimp-based, shrimp waste-based product. And this is some of the pictures from the work what we have done, and we have profiled the amount of waste and all those things, and we have also compared the quality of chitin. So I may be taking little more time to complete the rest of the slides. Please kindly bear with me. And here is a comparison between the enzyme-based chitin and the already available chitin. They are on par with the commercial one, so definitely the process can be adopted on the large scale. And this is some of the pilot scale trial, and some of the where it can be used. All those aspects I have placed it. Definitely I will share the presentation with the organizer also. And here is the picture of wet chitin and hydrolysate solution, and this is the final product. So what I would say, the mantra is this: if we are trying to utilize the shrimp processing waste, chitin yield is only 3%. At the end, if you process a ton, you may end up with hardly 30 kg of chitin. The price goes to around 210 rupees. But the protein, it is almost threefold. And if we can produce a better quality protein, the money what the industry or the processor will get out of protein is pretty higher than the money which we are going to get from the kiting. So this is the mantra. So this can be like the processor can be better convinced to recover the protein and go for the chitin production. So rather than conventional process, this can be very well done by a mechanical process or by the enzymatic process. So here is again some of the reports from the literature. So we don't need to much worried about this. Why I placed this slide? You look into the right side lower panel. I placed a picture. You can look into the color, the type of material which is there. This is the paste, carotenoprotein paste, which is again the residue from the enzymatic process. This can be a high value product for aquaculture industry for enhancing the color in aquarium fishes that can be utilized. So we have done some work on cuttlefish waste also. I will show some of the work on that. But what can be done is again the gelatin collagen peptide, and currently some of the industries, the cuttlefish skin, not the squid skin, that is very thin, and it's very difficult also in terms of workability. But the cuttlefish skin is very thick, and this can be simply washed, frozen, and can be supplied as a raw material to the collagen industry or collagen peptide industry or to the hydrolysate industries. So that can be done. So we have technology for the conversion of cuttlefish skin or squid waste into sort of industrial product. So this is a profile. Again, we just tried making the primary data available. What is the major portion of waste, what can be done. And this is some of the work on cuttlefish skin as influenced by the chill storage condition, and then this unpublished work, and also the drying. So what I'm trying to say that these are all the better raw material for making hydrolysate, if at all not going for the gelatin or collagen. We have done the work on collagen from cuttlefish skin also, and it is definitely a sort of different quality compared to the other skin of material. This is another industrial product called cuttlefish waste or squid waste. Hardly one or two industries say for amalgam than Kalasona ingredients from Gujarat, amalgam from Cochin, like they are exporting this product. And the process involves allowing the autolysis to happen, then concentrating into a paste form and preserving it with the acid, say for phosphoric acid, food grade acids. Then in drums, 200 kg drums is being exported. So you can see the amount of prices again somewhere around 40 to 60 rupees that goes. So it got a tremendous application as a feed attractant in aquaculture feed formulations. So even that can be thought of working for the research purpose, then as well as for the industry purpose. Then the another one is squid meal, simply the entire thing dry and pulverize, and this is also being exported for the better price, in fact. So this is from my side. So with this, I wound the presentation saying that there is a huge scope on fishery waste. If we look on protein based products, so these are all some of the pictures which we usually display when the students and others comes to the lab from fishery waste. With this, I thank the organizer for the opportunity by saying that if we want to achieve the sustainability in fish processing as well as in the environment, we have to take all the three components. Industries have to come with something called a social responsibility. The primary processor, I am exporting the material to certain country, but I make sure the waste what I generate is being utilized. So that's of implementation. Once enforced, probably then there will be a huge demand in terms of research. Already it is there, but the conversion, the translation from research to industrialization, that can happen. So thank you. So I'm stop sharing the slide and open for the discussion. Am I audible?
Yes, sir. You are very much audible, sir. Thank you for elaborative presentation, sir.
Thank you, Faisal.
So
Thank you, sir.
now the topic is open for discussion. If you are having any question or query, you can please ask.
Yes.
Yes, any questions?
Or you can suggest me also to improvise this presentation. Probably if it is not meeting your expectation, you can suggest me like how best this would have been done, because most of the people are from teaching side. Yeah.
Yeah, Dr. Bola, sir. Sir, you are having any question? Hello.
Hello, I'm Shiny
Yes,
from
Shiny, please.
from Kufos, and the presentation was too beautiful, and it was too elaborative, very much useful for us, especially from fish processing side, and the issues or problems I felt with dealing with the fish processing waste as a raw material for developing various value added products is its freshness is too important for developing the products. If for example, if we will be trying to extract high grade gelatin from fish waste, then the freshness of the waste will be very much important, otherwise it will be just a fish glue. So that also should be considered, that the raw material, its freshness. That's all.
Thank you, Shiny. So
Yeah.
I agree very well with you. So the freshness of raw material is quite important. So no one can deny that. But if we think of, I'm just giving the information. So I agree with you. Then the next thing is, why in industry you don't get the fresh material? You have to, if you are ready to pay a little more, they are ready to, because the inputs again they have to go for icing, otherwise freezing and cold storage. The cost has to match. So if the raw material goes for the high value products, if there is an industry, then definitely it's like interlinked, it will hit back. Then there can be a rise in the cost. When the cost goes, the person also will demand. So it's all mutual events. So one side, if the industry development happens in high value products like gelatin, collagen, peptide, then on the other side you will get the fresh skin. Why I'm telling this, already the skin is being frozen and exported from India as a raw material, especially to Japan and Thailand. So there are people who collect, like they purchase, they send it. So definitely there the freshness is maintained. So this can happen over the period when the growth is achieved in terms of industry's development for high value products. Thank you.
Yeah, thank you.
Anybody else with a question or a query?
I think I have some of my own seniors also, like Anik sir is there, Muruganathan sir is there. So no
Any
queries.
feedback, any interaction you would want to do, you can turn on your microphone or even respond in chat. Mostly thank yous are coming, sir. Maya Raman is saying thank you.
Thank you, ma'am. Thank you very much.
If there are no questions or queries, we may consider the session to be concluded. Dr. Faisal, you would want to present? Yeah. Vikas Kumar Patti, do you have to ask a question, please? You have raised your hand. Please ask a question. You can turn on your microphone and you can ask. Vikas Kumar, Dr. Vikas Kumar.
I think you have to unmute Vikas Kumar Patti.
Anyways, I don't think there are any further questions.
Okay.
Dr. Faisal, you would want to present formal vote of thanks?
Okay, no problem, sir. Sir, on behalf of organizing committee, we thank you for your valuable and informative talk. Thank you very much, sir. In future, we will have more collaborative work. Thank you, sir. Thank you.
Thank you, Faisal. Thank you. Thank you so much for the opportunity.
Thank you, everyone. Let's join back at 2:30 for the next session. Thanks a lot.
Thank you. I'm leaving the meeting.
Sure.